is less than 2, or x minus 1, if x is greater than or equal to 2. So it's a piecewise defined function. So we're going to graph the two pieces separately. And we'll put the pieces together on one big graph. So first one is y equals 3. What does y equals 3 look like?
Horizontal.
Horizontal line. But I don't want the whole graph, I just want the piece where the x values are less than 2. So there's an x value of 2. Where are the x values less than 2? The left? Do I want circle or dot there? Circle?
Or-
And get rid of the rest of that. Here's our first piece. Second piece is y equals x minus 1. Let's do slope and y-intercept. What's the y-intercept?
-1.
What is it?
-1.
You have to write it as an ordered pair.
0,
-0,
-1.
-1. What's the slope?
1.
1.
1, so up 1, over 1. Connect the points together. But I don't want the whole graph, I only want the piece where the x values are greater than or equal to 2. There's an x value of 2. Where are the x values greater than or equal to 2? To the right? Solid dot or circle?
Solid.
Solid dot. I want to keep everything to the right. Get rid of this. Now, let's go back and find those endpoints. What is this point?
2, 3.
2, 3. And what is this point?
2,
So if I plug in 2, get 1. Piece of a horizontal line. And a piece of a slice line. Does it pass the vertical line test?
Yep.
Even at 1, does it pass the vertical line test?
Yeah.
Yes, because one point is included, but the other one is not. So it does pass the vertical line test then. Okay, other ones from it says, use the vertical line test to determine whether the curve is the graph of a function of x. If it is, state the domain and the range of the function. So first, is it a function? Does it pass the vertical line
Yes.
test? Yes, even at -1?
Yes.
Yes, because 1 is an open circle, 1's a solid dot. So yes, it is a function. Domain. So we can find the domain by taking all the points and smushing them into the x-axis. Remember, domain is x coordinates. If I smush all those points into the x-axis, what would be covered?
All around
So if I smush those all into the x-axis, that would be covered. So that's x values between -3 and 2, including the endpoints. To find the range, smush all the points into the y-axis. What would be covered on the y-axis? -2 or
0, 3.
less than 0, or excuse me, greater than 0 and up to 3. Why did I just put greater than 0 and not greater than or equal to?
Because it doesn't include.
Because there was an open circle there. So remember, domain is swish the points to the x-axis, range is swish the points to the y-axis. Right, other ones from 2.2.
Here you go.
40? separately. And then come back and graph them for one big block. I strongly recommend it.
Yeah.
Most people who try to do it all on one get it wrong. So I strongly recommend you do the pieces separately. All right, what does y equals -1 look like? Horizontal line
Down one.
at -1. But I don't want the whole piece, I only want the piece where the x values are less than -1. Open circle there. Less than -1. So I just want that piece of that horizontal line. What's that point?
-1, -1.
-1, -1. Second piece. Y equals x. That was our identity function. I want the piece of that between and including -1 and 1. What's that point at the left end? -1, -1. What's the point at the right end?
1, 1.
1. Last piece, y equals 1. What does that look like?
Horizontal.
Horizontal line. 1. But I only want that where the x values are greater than 1. And what's that point?
1, 1.
That's 1. And horizontal line, slanted line, horizontal line. That's it. So once again, this word isn't that important, but continuous or discontinuous?
Continuous.
Continuous, the piece is all